EOS and Tron are way ahead of them in terms of adoption. So
a little bit of Chinese bias there.
No. No, well, yeah, they both have the president. Yeah, no, just empirically on that. In terms so I was just wondering whether or not you feel that they're using their strategy is the right one as well.
So first off, Tron is Ethereum. They took literally Ethereum Java, forked it, put DPoS on top of it, and then bought BitTorrent for legitimacy. And there you go. Great. I had dinner with Justin last night. We had a lot of fun together. He's a fun guy. EOS is just a bunch of Amazon servers bolted together. They're not even Byzantine tolerant. 90% of supply is owned by 1% of the people, and the founders raised $4 billion with a straight face, told everybody they have no moral or fiduciary obligations. I can't imagine how they're not going to be in jail at some point, or at least enduring some major fines. As for deployed infrastructure, it's easy to deploy things to Amazon. It's easy to deploy things to Rackspace. So when you build a simulacrum, a very poor simulacrum of that model, lo and behold, people can deploy gambling stuff and other crap stuff to your system. Great! What real problems have they solved other than introducing problems and headaches for regulators? None. You know, and then they lie. And they don't even, no one has critical thinking in that ecosystem. Let's say you can go to 500,000 transactions per second. Let's just thought experiment. Let's say each transaction is a kilobyte. So how much data are you producing in this? 500 megabytes. Okay, so how many people here have a 500 megabyte per second internet connection? Okay, so how do you keep up to date with the network? How do you decentralize that? You can. And then also, what's the size of your blockchain? It's petabytes. Get exabytes. It's either Google or the NSA that measure blockchain. Pick which one you want to get it from. It's insanity. It's just insanity. It's bereft of reason and common sense, and it's just yet another Dan Larimer adventure with some good, some bad, some real ugly. And they just keep getting bigger, and they just keep causing more problems. So I don't even consider them a competitor. I look at them in the same category as, okay, great, move on.
As you can tell, Charles is very shy with his views. So with that, I want to open up the floor for questions. Who's got questions, please? Straight up? Okay, so there's one over here, one over there, one there, and one there. So we're going to start with this side first.
Charles, excellent talk. Just a very quick question. Philosophically, how do you feel about the openness of rules in a smart contract? I mean, I can see from one side it's good to keep the rules transparent, but I can also see, for example, company managers wanting to keep certain rules secret for competitive or other reasons.
Right. Privacy and computation is absolutely essential, and the reason why we're doing this is not because we want everything to be open. The reason why we're doing this is the cryptographers and audience can tell you is it's super, super duper hard to have private computation in a general purpose. You know, we have techniques like homomorphic encryption, and it would be in an ideal world perfect to have a situation where you can do a Google search and Google doesn't know what you're searching for. You can navigate with Google Maps and they don't know where you're going. And obviously that your business logic for your smart contract is protected. But in the general case, that's a really hard problem. Now, there's been some progress. Zcash published a paper with Matt Green called DEXE, and it's a really cool paper. There's a lot of meat to it, very hard paper to read, that kind of explains ways to do private computation. Another model is that you actually do the computation on a private server and then use a technique called verified computation to show that the computation was done correctly, but you do not necessarily need to disclose the underlying output or the program. So there's a framework that Microsoft Research created called Pinocchio back in 2014 that shows how to do this in a general purpose case. And if you're willing to accept the loss of generality, there's a follow-up called Geppetto that allows you to do this in a much faster and more parallel way. But the long and short is it's a very hard problem, but it is a problem that people seek to solve. And there's a whole family of academic papers, some we've written, some other people have written, that have good solutions or partial solutions to these. Now, eventually, once you have the ability to have private computation, then it opens up a more philosophical conversation of when should the computation be private and when should it be open and public. And you know, that's a really interesting conversation, and it's one that we're already starting to have in our ecosystem. As an example, you could always imagine Silk Road, the canonical Batman of the cryptocurrency space, it's entirely possible to imagine a private version of Silk Road where the operation of it runs on infrastructure kind of like Ethereum, what's called the next generation, something like that, but it's intrinsically private. So you don't actually know what's being bought and sold in the general sense. You don't know who's using it in the general sense. And what are the social consequences of this, or assassination markets or other things. In fact, there's a great paper that was written by Aline Shi out of Cornell University called The Ring of Gyges. So Gyges was this Greek, and it had this invisibility ring. And basically the paper explores what are the naughty things that you can do with smart contracts, and kind of touches on how we design these things and so forth. So I encourage you to read that paper, and if you want to talk to Elaine, she's a great gal to talk to, a tenured professor over at Cornell, and she works in this area at cryptocurrency research group called IC3.
Thank you. In the middle.
Thanks, Brian and Charles, both for this wonderful topic. Excited for debate and discussion with you. If I may, I'll give Marisa a few questions, 3 questions in the granular process.
Can you speak a little closer to the mic?
Sure. Can you hear me now?
Short questions, yes.
Thank you. I want to thank you both first. And then I want to start a series, a few questions ranging from concrete to more abstract level. So if we start from the 8th room that you co-founded, Charles, did you, at the time when you founded the company, did you envisage or did you foresee up to a certain stage, as what you had last year, the big traffic jam of the data? And here, in the local market, in the blockchain tech team or technical people tend to declare that Ethereum has to die out of this. So my simple first question is, did you ever foresee this? First. Secondly, related to this, I've been thinking that, humbly, I've been thinking, if we talk about this blockchain with the application of IoT in the future, and a smart contract is indispensable, but actually to design a good and lightweight smart contract, which would serve as a locomotive to move everything, from information to the real goods and services. Probably we need to, fundamentally, to think out of the box about this smart contract. Given the crypto, all the possibilities, technicalities you've been describing before the post-quantum era, which means everything can be managed by quantum computation power. If we take a look at AI, some people, at the GPU time, what they contemplate or accomplish, actually were able to accomplish under the GPU. So of course capacity, hardware capacity is a way to improve it or solve the problem, but it isn't real a methodological, philosophical way of solving that. So my second question is it possible to think philosophically, up to a certain stage, we can design smart contracts in which the trust or the mutual peer trust can be designed by other ways, such as the legal way. So you don't have to write so many coding. Maybe so lengthy so that we could have a lightweight, slim sigma way in the computational industry.
Right. Okay, hang on. Let's take the first 2. So first, with respect to what did we think when we first created it, we didn't actually think the protocol would be successful when we first started talking about it. This was back in December of 2013. Somewhere around April of 2014, we started developing at least a rough idea that there was merit and a lot of people would want to do this, especially after we built a few proof of concepts and wrote the yellow paper. One of the design flaws of Ethereum, or at least the initial version of Ethereum, is this concept of replicated computation. So basically, you move at the speed of only what one person can do. It's not a distributed system, so it's like a pie at a table. You can add more chairs around the table. It doesn't make the pie bigger, it just means everybody gets a slightly smaller slice of pie in terms of the total amount that they eat. Now, moving from replication to a distributed or sharded system is a very big topic right now, and it's something that's being studied by big companies like Visa and IBM, all the way to my own company and companies in the space. And it's less about can we do this, and it's more about what do we give up when we do this. So is it okay to lose Byzantine tolerance, to go from 50% to a third to a quarter? That's an example. is it okay to have a backbone of your system be controlled by some special group of actors that you trust a little bit more than you trust every other node? Okay? Is it okay for people not to see the entire state of the system, to never have a chance to see the entire state of the system, so no one actually possesses the full blockchain? What are the consequences of that? And is it okay to lose data from time to time? Like, it is entirely possible in a distributed system for one of the nodes to go down that just so happened to have some piece of information that's now lost forever. You can verify if it comes back because you can check a hash, but it's gone until they return. Okay, so that is a conversation, and it's more philosophy than technology. Research allows you to move the trade-off profile, which means that you give up less to keep what you want. We do that, other people do that, but ultimately you have to give something up. And we will have next generation protocols come online that solve that problem this year, next year, and throughout the coming years. And it's somewhat Darwinian. The market will decide which ones end up being the standards. Okay. Now, with respect to your second question, I think there's an orthogonal. The concept of smart contracts and the environments that the smart contracts run is an orthogonal thing. So first, there's a pipeline. You have to model intent, then you have to implement it. Then there's an environment that you run it in. The question is, where should you run it? Well, you can run all of these things on a server. In fact, that's what Fabric does. That's the whole concept of chain code. You say, Bob over there, he runs the code. You can use verified computation and create a whole marketplace where anyone can run your computation. And then basically they produce a proof, and the proof is what you verify on chain. So you go from arbitrarily long computations to constant size proofs that validate in constant time, like checking a hash. Okay? So you can do that. And we're having a big conversation about what is the optimal infrastructure to do these things. And my opinion is there is no one answer. It's a heterogeneous issue. For example, if you look at the gambling case, like if you're playing poker, this is an interactive game. And frankly, this should be done probably with multi-party computation, because you'd have a situation where you use the blockchain as a trusted bulletin board, you use gossip to find each other, so that's where player matching occurs, and then you use the blockchain as an entry and exit point into the circuits. But the actual game itself is ephemeral. It has a beginning, a middle, and an end. People are interactive, and that works at the speed of the players. This is actually something that gaming companies are exploring for online games. So if you ever played Dota or League of Legends or these things, a lot of the architecture is fundamentally peer-to-peer. So you use the servers of Riot to find each other, host the game, and keep the game somewhat in sync with the rule set. But the actual hosting of the game, the meat and potatoes of it are done by the players themselves. So they're kind of eating what they kill. That model works very well in interactive environments, and you can go from games to other interactive relationships. Non-interactive probably can be done through verified computation, and yes, you can do sharding to actually increase the overall capability of the environment. So I think that that it's less about can we build some sort of super Roper machine that becomes the world's greatest computation layer and it's going to run everything, and it's more about just sorting out what you want and where you want to run it, how you want to run it, and also what are you willing to pay and what are you willing to give up for use of that infrastructure. For example, are you willing to trust that someone maybe control your money, or are you willing to remove some of your privacy, knowing that somebody will be able to see what you're working on? If you're a hedge fund, probably not. You don't want your trading secrets to be revealed. Okay, so maybe you have to do a different model. If you're talking about open source data, like folding proteins, who cares? It's a public good. It's going to be disclosed to the public anyway. So in that case, you're more focused probably on cost and latency. How long is it going to take for this thing to get done so I can actually use it and meaningfully do something with it?
Maybe Margaret, we'll let somebody else have the next question first. There was another question on this side. Yes, down there and then over there. Yes.
Hi, Charles. I want to ask about the smart contract. Some smart contracts will need to get data from the real world. So we will use oracles. The oracles itself can be usually centralized. The smart contract itself is decentralized, but the oracles are usually centralized. So Is there a better way to do this? Or does Cardano has a better solution for that?
So it's a fundamental issue. How can Bitcoin know its own price? How can Bitcoin or Ethereum know who won the Super Bowl, or if Hillary Clinton won or Donald Trump won the election, or even who is Hillary Clinton or Donald Trump, right? If there's no a priori way for the system to deduce within the axioms of the system, the rules of the system, some sort of knowledge, then you need an injection of information into the system, whether it be state or value, whatever it might be, to inform the system of how to act. So I, as a smart contract developer, would write some sort of contract, and I would have an event that I would program in, and I'd say, if this occurs, do this, if this occurs, do this, so standard control flow. But then, you're right, someone has to tell it. So the simplest case is that I just say, Cliff, you're going to tell it. Okay? So that's the authenticated data feed, and that's the Bloomberg business model to get your terminal. That's the Reuters business model. There's a lot of people who run down those roads. But then you say, well, hang on a second, Charles, doesn't that just remove all decentralization from my system? It's almost like asset-backed cryptocurrencies. You say, oh, well, this cryptocurrency derives its value from gold. Is it really a cryptocurrency then? Because somebody has to hold the gold. And what if that guy runs away with it? Or what if the regulator shuts them down? Like, what if the tether in cryptocurrency, the backing kind of gets removed because the banks get shut down, right? So it's the same situation with the Oracle. What if the Oracle is dishonest? So there are an interesting spectrum of projects that are trying to at least resolve this problem, like Augur, using some things that the TruthCoin guys came up with. PCA is what it's called. And they say, hey, can we create like federated weighted data feeds? And there's this notion of truthiness. And if you have sufficient truthiness, then it's okay. If you don't have sufficient truthiness, it's probably not okay. Okay. But then there's a referential issue of credibility. How do we know that you're not lying? And even if you generally tell the truth, well, what if you lie in this particular case? Like 70% honest, 30% liar. Is that okay? And it's usually situational. It's connecting the value of your personal connection. Another option is maybe you can use ML and trusted hardware in a really clever way to scrape data and have a machine actually tell us. So there's a really interesting paper out of Cornell called Town Crier. And what they did is they took Intel SGX, which is built into all your laptops if you have an Intel laptop, an Intel chip, and it's a trusted hardware module, and they actually run a scraper on it that goes and queries the web, looks for information, and builds some sort of semantic graph, and it's able to actually search for events. So it can go look at NFL.com and all these other sources of data and find out that the Broncos beat the Patriots or something like that, or look at CNBC or whatever and find out that Trump beat Hillary. But it can do this through trusted hardware, which means that the hardware actually can't lie. So, and it can actually create a semantic graph and can wire things together in just the right way that it can weight different news sources. So it can go and know that there's this collection of sources which are media, BBC, Fox News, CNBC, Sky News, and so forth. And it can say, okay, if 90% of them are saying the same thing about this event that I've discovered, it's probably true. Yeah. So you can build a system like that. What's nice is you've disintermediated humans. You've created an algorithm that, frankly, anyone can run. You can run this on your computer, I can run it on my computer, and if you trust the hardware to do it, it means that you don't even actually have to designate in the smart contract that one source is going to provide that for the event loop. Anyone can trigger it. That's the power of Town Crier. But then, of course, your trust now reduces to you trust Intel to have SGX be secure. Probably a somewhat reasonable assumption, but it still means you have to trust something. So that's the issue with the notion of information. If you can't deduce it, it's an event. Someone has to tell it to you. And whether it be the computer telling it to you, you trust the hardware, the circuits, and the engineers who built them, or it be Cliff telling it to you, or it be Cliff and his friends telling it to you, or Cliff and his enemies telling it to you, that's your trust model. And it's up to the smart contract designer and the users of the smart contract to make a decision of what is good enough for their domain. This is why in all things, especially security, a multi-model approach is very necessary. When we build aerospace devices, like we build rockets and other things like that, you notice that they have multiple redundant systems. So if system A fails, system B kicks on. If system B fails, system C kicks on. Similar to security, you have redundancy. So you say, well, you know, if this is flying, I'll have a backup system just in case. And if that fails, I have a backup system just in case, and so forth. And, you know, the value at risk is what's going to determine how critical this is. For $5 in value, does it really matter? No. For a multi-billion-dollar trade finance deal, maybe we do more. And life goes on.
I just read recently that Chainlink has a relationship with the Deviable Town Crier. Do you know what?
That's a good question. I don't know. Did they actually commercialize Town Crier? I read the paper, but I didn't follow up.
So because of our hackathon